साथ delightful सा dessert break लेते हैं. Kit Kat Dessert Delight with crispy cocoa wafer meets chocolate coating for layers of delightful indulgence.
Hi everyone, I welcome you all for this session, which will be fourth session which I will be conducting of NPTEL GATE previous year questions. So in today's session, we will look at 4 questions from GATE Metallurgy 2014 paper. Mostly it will be mechanical metallurgy along with some crystallography. So 4 questions I have chosen. So what I will do is, like, firstly I will project one question and I will give you around like 2-3 minutes to solve that question. And when you think that okay, you have solved this question or attempted that question, then we will discuss the solution of the question. So who don't know me, I am like Swanand Telpande, PMRF PhD student in Indian Institute of Science, Bangalore. So I will be hosting this session. So let's start it. I will present my screen. Just let me know if you can see my screen. It will come up now. Can you just say yes whether you can see my screen or not?
Yes, sir.
Okay, sure. So I will project first question and I will give you around 2 minutes time to solve that question. Then we will go through the solution. So this is the first question. You try to attempt it. This is basically very easy question. If you have studied mechanical metallurgy, then you will be able to answer this question. So in comment box you just write the answer, like option, which is the correct option. Then we will go through the solution. Okay, so Devendra guessed it to be A. Vikas, what is the unit of dislocation density and stress intensity factor? So if you need to see the question, I will just project it once more. I will give you like 1 minute. Okay, then we will go through the solution. Okay, so I will go through the solution now. I have given you enough time to guess it. So again, this is question number 4, GATE Metallurgical Engineering 2014 question paper. The respective units for dislocation density and stress intensity factor are: option A is meter square and MPa meter, option B is meter square and MPa meter root meter, option C is meter minus 2 raised to power minus 2 and MPa root meter, and option D is meter raised to power minus 2 and MPa meter. So firstly, what is dislocation density? So the dislocation density is defined as length of the dislocation per unit volume. So the length is meter, per unit volume is meter cube. So this will be 1 by meter square, which can be written as meter raised to power minus 2. Hence the unit of dislocation density will be meter raised to power minus 2. Now the stress intensity factor, which is K, is the formula of stress intensity factor is sigma root pi A, which basically means that it is the function of stress and it is a function of the crack length, and stress is defined in pascals or megapascals, and A is basically the length, which is in meter. So sigma will be pascal or MPa, and A will be meter, and under root meter will be meter raised to power half. So the unit of stress intensity factor will be MPa root meter. So meter raised to power minus 2 for dislocation density and MPa root meter for stress intensity factor. So the correct option is option C. I hope this is clear, Devendra and Vikas. You have any doubt in this?
Sir, please repeat again, sir. I have lost my connection.
Oh, okay. I will just brief you like what I explained. So what the dislocation density is defined as length of dislocation per unit volume. So the length is in meter and unit volume is meter cube. So basically meter by meter cube will be 1 by meter square, which you can write as meter raised to power minus 2. And the stress intensity factor, which is K, is defined as a function of stress as well as root of pi A. Hence the stress unit is MPa, Newton per meter square, and area means like crack length is A, which is in meter. So root of meter is meter raised to power half. So the unit of stress intensity factor is MPa root meter. So combining this, the correct answer is option C. I hope this is clear, Vikas.
Yes, sir.
Okay. So I will now go to next question. I will project it for like, let's say 2-3 minutes. You try to answer the question. And I have given also the reading material. If you don't know these concepts or you have not studied fracture or dislocation theory, then you need to refer to this reading material to get to know everything, every concept behind this. So now I will project question number 2 for this session. This is question number 17 of GATE 2014. Here you need to find the stress amplitude. Basic formula is there. If you know that formula, then you can easily answer this question. So I will give you 2 minutes to answer this. $50 MPa. Okay. And Devendra, you wanna try that question? Otherwise, we will proceed with the solution. Okay. Let's start with the solution of the question. This is GATE 2014 Metallurgical Engineering question number 17. A steel rod was subjected to a fluctuating stress cycle that varied between a maximum of 400 MPa in tension to a minimum of 300 MPa in compression. So what is the stress amplitude in MPa? We have to find out. So a fluctuating stress cycle means fatigue. So in this thing you can see that here the stress is fluctuating across the mean stress, and we need to find out sigma A, which is the alternating stress here, and this is like from peak to peak is known as one cycle of fatigue, and this is delta sigma is the basically sigma max by sigma mean, and this is the overall stress cycle of fatigue, which is an alternating cycle. Hence, and these equations are given as like this: delta sigma is basically sigma max by sigma mean, which is basically the stress range in under which you are like fatigue, you are doing fatigue of the sample. Sigma A is basically the alternating stress, which is given by delta sigma by 2. Delta sigma is basically this delta sigma divided by 2, sigma max by sigma min divided by 2. So this is the alternating stress, and sigma mean is given by sigma max plus sigma min by 2, which is this one. So you need to find out stress which is alternating stress. So you have to find out this amplitude over sigma mean, how much it is. Hence, now what in question it is given is like a maximum of 400 MPa in tension and minimum of 300 MPa in tension. So this is tension compression fatigue. So if I draw a stress cycle of this, so it will be like this, where this will be 400 and this will be 300 in compression. So here maximum is 400 in tension and minimum is 300 in compression. Hence now if you want to find out this value, sigma A will be given by sigma max minus sigma mean by 2. So sigma max is basically 300 minus of 400. So you have to add these two values and divided by 2. So the answer will be 350 MPa. And you should remember that one of the mistake which you have done earlier is like you consider 400 as maximum and 300 as minimum. So what you did was like 400 minus 300 divided by 2, hence the answer was 50. But you need to see if this is in compression, this will be negative. So either one of this sign or this sign you need to subtract. Hence 300 minus of minus 400 divided by 2 will be 700 divided by 2, which will be 350 MPa.
Sir, can we consider if the minimum, so we can take negative sign?
Sorry?
Sir, we can consider, whenever the minimum compression is given, then
Yeah. Actually this was some like error. It should be 400 minus of minus 300. Actually in addition it doesn't matter. So 400 minus of minus 300 it should be. So sigma mean you should take of compression and sigma max should be of tension. Always remember. And whether if it is tension fatigue, then your sigma max will be the stress which is higher and sigma mean will be the tension stress which is lower. And in compression fatigue, sigma max will be the lower magnitude of negative stress and sigma minimum will be the higher magnitude of negative stress. I hope this is clear. Okay, any doubt? So sometimes they will ask regarding mean stress, sometimes they will ask regarding alternating stress. So you should know like what you need to answer, and these are the basic formulas which I have shown in the slide, where you can use to where you can calculate sigma mean also, alternating stress also. Even I will tell you regarding R. R is basically, I will just a second. Where R will be defined by sigma mean by sigma max. This is the stress ratio. So you have to know this equation also along with these equations. So you will be able to solve every question related with fatigue along with these 4 equations. And when it is fluctuating stress, you will know that it is fatigue. I hope this is clear. Okay.
Sir, I am saying that whenever the compression is happening,
okay,
can we take the minimum always in negative?
Yeah. We have to take in every stress which is in compression, you have to take negative in this equation. Every stress which is in compression. Okay, whether it will be minus 50, it is mentioned that in compression it is 50 MPa, so you have to take minus 50 always in every equation.
Yes, sure.
So for example, let's say tension compression cycle. I will just So here if you look at this cycle, so this is tension side and this is compression side. Let's assume that the maximum peak is 100 MPa here and the minimum is 100 here in compression side also. Now you have to calculate sigma mean. So sigma mean will be basically sigma max plus sigma mean divided by 2, right? So this will be 100 plus of minus 100 divided by 2, hence sigma mean will be 0, which is this point. And alternating, if you want to calculate for this cycle, so sigma A will be sigma max minus sigma mean divided by 2. So this will be sigma max is how much? It is 100. So in tension you have to take sigma max. So minus of minus 100 divided by 2. So this will be 200 by 2, which will be 100. So this is your sigma A, which is 100. This is for pure tension and compression cycle where both the magnitudes are same. When both the magnitudes are same, you will get sigma mean as 0. Always remember. And similarly, you can calculate for a compression cycle. Let's say you are doing compression. So this overall is negative. So here this will be sigma mean, this will be sigma max, and you have to apply same equations and you will get the stress. Okay, Vikas, is this clear?
Yes, sir, clear.
Okay. So now I will go to question number 3 and I will give you 2-3 minutes time to solve it and then we will solve the question. So this is a numerical where true strain is given of a tensile specimen and delta L is given, the change in gauge length. You need to find the final gauge length of the specimen. So if you know this formula, some simple mathematics can give you the answer. I will give you 3 minutes to solve this. True strain is 0.405 and change in length is 5 mm. So you have to find out the final length of the specimen. I will give you couple of minutes more to solve it, then we will solve it. 1 minute more, then we will solve. Any one of you have solved? Okay, Vikas has guessed it to be B. Okay, let's solve this question. We will go step wise, like what is the formula and how we can solve it, and directly coming to the answer. Okay, so this is question number 27, GATE Metallurgical Engineering 2014 question paper. A tensile specimen was deformed to a true strain of 0.405. The change in gauge length was 5 mm and the final gauge length of the specimen in mm is option A is 10, option B is 12, option C is 15 and option D is 18. So firstly, true strain is given by this formula where epsilon represents the true strain here, and which is given by ln of or ln of final length by initial length. Here you can see this is the final length where divided by the initial length. And so now we will try to solve it. So let's say this epsilon we can like divide it in L naught plus delta L, right, divided by L naught. Same thing we have written in a different way where delta L is the change in length. So we have given delta L to be 5 mm. It is specified the change in gauge length is 5 mm and true strain, which is epsilon, is given 0.405. Okay, so we will put same thing in this equation, 0.405 ln of, so L0 by L0 will be 1 plus 5 by L0, right? So ln means this is 1 plus 5 by L0 equal to e raised to power 0.405. So let me calculate e raised to power 0.405. So e raised to power 0.405. Can you tell me, anyone, what will be e raised to power 0.405 if you have calculator?
$1.499.
Okay, 1.499. So 5 by L naught will be 1.499 minus 1, right? So I have taken this one. So L naught 5 by L naught will be 0.499. So L naught will be 5 by 0.499. So we can consider this to be as 0.5. So this will be 10. So the initial length we could get, which will be 10 mm. Now we have to add the change in gauge length, which is 5 mm, to the final length because we require to answer final gauge length. So L which is final, will be L naught plus delta L. So here 10 plus 5 is 15 mm. So the correct option is option C. I hope this is clear. This is simple mathematics. So you need to, in this question you need to remember that you need to know this value, right? So you will have gate metallurgy calculator, which is a online calculator. So you need to practice using that calculator to find out this value, e raised to power 0.405. There will be other questions as well where you need to find. So you need to have practice of this gate metallurgy gate calculator which is used. You should know how it works basically. So the correct answer is 15 mm. I hope this is clear. Okay. So I have a few more formulas along with this. You should remember these two formulas also. Like where the epsilon, you need to find two things here. Like similar questions can be asked in GATE exam. Here the true strain is given by ln of 1 plus epsilon e, which is the engineering strain. So this is basically the engineering strain. So you need to know the relation between the engineering strain and the true strain. Similarly for true stress and the relation between engineering stress. So sometimes similar question will be there where you will need to find out the true stress when engineering stress and engineering strain is given. So you need to know these two formulas also along with this. I hope the question is clear. Okay, so we will go to last question of today's session. So I will project this question is from crystallography. So if you have learned physical metallurgy, some crystal structures, then you will be able to answer this question. So I will project it. I will give you like 2 minutes to solve it, then we will solve that question. So here match the following is there, where you need to find out 4 different materials are given and you need to find out the crystal structure of those 4 elements and you need to pair that. So I will give you 2 minutes to do that. I hope you have guessed the answer. So because no, this is earlier one, right? This is basic crystallography question. So I will give you 1 minute more to answer this. Okay, so I have given you enough time. Now we will solve this question. This is question number 47, GATE Metallurgical Engineering 2014 paper. Match the elements in group 1 with their corresponding crystal structures in group 2. So group 1 is P is tungsten, Q is nickel, R is magnesium and S is polonium. And group 2 is first is HCP, second is simple cubic, third is BCC and fourth is FCC. So we need to find out the crystal structure of all these four elements. Coming to the crystal structures, basically in four crystal structures most of the metals or elements they solidify. So most common is FCC because it is a closed pack structure. So here you can see this is FCC lattice where in all the faces you will have atoms present in the structure. So the examples of FCC the elements which have FCC crystal structure are aluminium, calcium, nickel, copper. Like that, the bold structures are most common materials which are used. So you need to remember in FCC, aluminium, nickel, copper, these are the many things like gold, copper and platinum, lead, everything is there. So in FCC you need to remember these much of elements like solidify in FCC crystal structure. Coming to BCC, where one additional atom is present at the center of the unit cell. Here in this mostly manganese, iron and tungsten it will be present. And in HCP you can see magnesium, zirconium, zinc, cobalt. Like this the atoms will be distributed here in HCP structure. And simple cubic is polonium. So here you can see that tungsten will be BCC. Here you can see tungsten, which is denoted by W, is BCC. So P is 3. And nickel is basically FCC crystal structure. So Q is 4, P3, Q4. Magnesium is HCP, R is 1 and polonium is simple cubic. So S is 2. Sorry, this is a spelling mistake, it is S basically. So polonium is 2 simple cubic. So P3, Q4, R1, S2. P3, Q4, R1, S2. So the correct answer will be B. I hope this is clear. Basic crystal structures question was there. So you need to find out what different elements will solidify in which crystal structure.
Hello, sir.
Yeah.
Sir, last question, sir. Is there any method to predict by seeing the elements and
No, I guess this question is basically a knowledge based question. So if you know the answer, then only you will be able to answer. Otherwise, uh, basically in this type of question, like let's say if match the following is there, then it is easy. Like if you know only two or three of them, you can guess the correct option. But this is knowledge based, so you need to like learn these things, like which materials have FCC crystal structure, which have BCC and which are FCC. So in the bold letters these are common that you must know. No one will ask you about strontium and everything. So this is not mostly aluminium, nickel, copper, sometimes gold, silver, platinum, palladium, like that it will be asked. Lead is mostly asked. And in BCC basically it will be iron. So alpha iron is BCC structure, manganese, chromium, vanadium, all salts like basically NaCl forms rock salt structure. Even lithium like plus one valency. So Na plus 1 is there, Li plus 1 is there, K plus 1 is there, like that. So you need to, like if you know the periodic table, then it may give you hint like in what type of crystal structure it may form. So in HCP also, like magnesium will be most common, titanium will be most common, zinc will be most common, zirconium will be most common. So you need to learn these elements, like these are the common elements and these are the crystal structure of those elements. And in simple cubic only one or two are there, Basically, polonium is one of the widely known simple cubic material. So like that you need to learn only, or otherwise there is no other technique to know.
Okay, sir.
Okay, yeah. Any other question regarding to fatigue, fracture, crystallography? We have taken 4 questions regarding that, mostly mechanical metallurgy and 1 question of crystallography. So if you have any doubts, like, we can discuss over that. Apart from question also, it is okay. So I will sum up today's 4 question. So first question was like how we can, so it will give you feel of like what kind of questions are asked. So first question is regarding to the units. So if you have a fundamental any quantity, you should know units of that, or you should be able to derive the units of that. So that was the first question. Second question was regarding fatigue. So fatigue basic formulas you need to revise. What is alternating stress, and what is mean stress, what is R, like that the basic formulas you need to revise. And the third question was regarding true stress, true strain, engineering stress, engineering strains, how are they related with each other. These formulas you need to know to answer these questions. So when you study mechanical metallurgy, let's say you are in like you are reading true stress, true strain, or engineering stress, engineering strain. So what you do is like you just make one sheet where you write all the formulas related to that topic. So it will help you later to revise those formulas, and along with the formula you write the units of that as well, which will help you to solve multiple questions. And fourth question was basic crystallography. So you need to know Bravais lattices, what kind of Bravais lattices are there, 14 number of Bravais lattices are there, trigonal, tetragonal, rhombohedral, everything you should know about Bravais lattices. So and you should know which element solidifies in what structure, that you should be able to know, like that you must know actually in order to solve the question. So these were the basic idea behind this 4 question, like what, and similar question will be asked in every gate. Depending on that, you will be asked units, you will be asked to derive something on like calculate something on basis of some simple formula, which you should be able to know that this is the formula and I need to apply this formula to calculate the mentioned required result. And here also, like in question, you need to like, I will go to this question. Here you should read the question carefully. Every question you should read carefully. Where here 400 MPa was in tension and 300 was in compression. So you need to know that this is minus 300, not 300. So one of you made mistake that you take 400 minus 300 divided by 2, whereas it is actually 400 minus of minus 300. So it is 700 divided by 2, because you skipped this word in compression. That you need to make sure that you don't do such mistakes further. So read the question carefully and then try to see which formula fits in and then come to the answer.
Okay.
I hope this is clear.
Yes, clearly.
Okay, then we will stop this session and later we will continue with 4 more questions of same 2014 gate paper. Okay.
Sir, one thing I want to
Yeah.
add up, sir. Sir, the way you are teaching, when you conclude all the content you teach,
Okay.
it's really awesome, sir. And it's very easy to understand. You highlight basically the topic which should be covered, and this is helpful for us and the other ones. So thank you for the way of teaching.
Yeah. It's like I need to summarize like what kind of topics and what kind of questions are there. So you need to be better prepared for those type of questions. So basically in crystallography, match the following will be there. You should know what elements solidify in what crystal structure. Similarly in fatigue, what formulas are important related to gate. Then even though the question asks for certain thing, I also try to add up more things in that, so that you may know what are other formulas also which can be asked, and you need to solve those questions with the help of some different formula. So you can like summarize all those things, and you can jot down in single sheet all the formulas and everything, and it will be
Yes.
helpful for you to solve similar or different question which will be more or less related to the same question in a better manner. So you don't need to
Yes.
go over the textbook again to find the formula.
Yes. Yes.
Okay, so we will continue in next session, next Wednesday,
Thank you.
6 to 7 p.m. Okay.
Thank you,
Yeah,
sir.
okay. Bye.